sun is almost an endless source of energy, and it's one of the cleanest ways to tackle climate change. Unfortunately, we can only use solar energy during daytime to generate electricity, as we have days and nights on Earth. But the sun is always available in space. We can then use mirrors in space to illuminate large solar power farms locally to continue to generate clean energy. We call this concept orbiting solar reflectors. We can use these reflectors to illuminate solar power farms around the Earth in the early morning and early evening hours. Using an orbit close to the Earth, we can extend the day of the solar power farm for a few hours longer and so continue to use solar power for electricity generation.
The mirrors would be made of thin, lightweight and reflective material, similar to kitchen foil and supported by a structure. They can be as large as a kilometer across to provide enough illumination. The question is then how to create such a huge area. The tiling process is a solution to this. In your home, you might have seen a large area made of a number of small tiles, such as in the bathroom or kitchen. Similarly, a large space mirror of hexagonal shape can be constructed using small identical mirror tiles of triangular shape. The hexagonal shape of the overall mirror can be expanded symmetrically to any size using the same triangular unit. The number of triangular shaped tiles can be exceptionally large, possibly in thousands. But the rocket launching these into space has size limitations. To get around this, we can manufacture the mirrors using 3D printers in the space. Then we only need to launch the raw materials.
The illuminated region would be about 10 kilometres across. The reflector would therefore only illuminate large, remote solar power farms from tens to hundreds of square kilometres, rather than individual rooftop solar panels. Even though these farms are typically far from cities, the reflectors would be steered not only to point in the right direction, but also to maintain the direction accurately, so that the reflected light remains inside the area of the solar farm and does not spill around it. Unless you're very close to one of the solar farms, you would be unlikely to notice any difference in the illumination around you. Also, the reflectors would only be illuminating the solar power farms when they are visible to the reflector. When the solar power farm is no longer visible, the reflector would orient itself in a way that no light is reflected to the ground.
The global space industry is growing and attracting investments useful to explore new ways of harnessing space resources for the benefit of humanity. Over the years, the solar power industry has grown and the capacity of solar power farms has increased significantly. However, energy generation from the sun is limited to hours of sunshine. Orbiting solar reflectors integrate the space industry and the solar power industry. Technological advancements make it possible to manufacture and assemble reflectors in the space environment, overcoming the need to pack large reflectors into a rocket. Furthermore, the cost to launch a satellite into space has reduced in recent years, which enhances the economic viability of orbiting reflectors. These reflectors can increase their value by providing energy to multiple solar power farms around the world. By delivering extra sunlight from space, the solar reflectors would reduce the quantity of fossil fuel being used.
We expect that the impact of the additional light on the natural environment would be minimal. These mirrors are designed to be flat, meaning that the level of illumination will be lower than the daylight levels, and the highest illumination will last only a few minutes. Again, we can also control the mirrors in a way to reduce the illuminated area outside the solar power farm.
When the mirrors are illuminating the solar power farms, they would be visible in the sky, but their size would be about 1/10 the diameter of the full moon. So they would appear as a small bright disk in the sky. Early morning and early evening hours are already quite bright for humans, so the mirrors in the sky may not even be noticed as such. The reflector operations would be planned carefully so that we can minimize the impact on astronomy and night sky observation. The mirrors would disappear in the night sky as soon as they finish their operation.
When no longer needed, the mirrors would be disposed of to avoid creating space junk. And this would be done by using the pressure of sunlight as a propulsive force. This is called solar sailing, and it works in much the same way as sea sailing, but instead of being propelled by air pressure, we are propelled by solar radiation pressure. And this means we also do not need to carry any fuel.
Ultimately, by using orbiting solar reflectors, we can help accelerate the transition towards clean energy, which would help us tackle the impact of climate change and reach net zero with space-based solutions, literally bringing space down to Earth.